the test number 4 contain question 1 and question 2. The graph of the exponential function and graph of the logarithmic function. We practice both. I don't know, so we practice here another number maybe, but it's the same idea. It's the same procedure. Suppose graph this function, f of x equal 2 to the minus x. Okay, guys, I want to explain super slow down. Any question, please don't hesitate to ask me. Okay, we have time. We have 3 days to do this review. And I suppose that you have no problem. Okay. Well, immediately I see, wow, we have a negative exponent. A negative exponent is reciprocal. So you consider it like that. 2 to the minus 1 raised to the x is equivalent, no? And also it's equivalent 1/2 raised to the x. So basically, when you have negative exponent, it's the reciprocal of the base. So the base is not 2, the base is 1/2. So ready to do the graph of the exponential. I know approximately what is the shape of this curve. Remember, when the base is less than 1, it's exponential decay. So we have two kinds of exponential, quickly. Exponential growth look like that. Exponential decay look like that. I suppose in our case look like that because the base is 1/2. Okay, decay, growth. No growth. Growth is when the base is greater than 1, 2, 3, 4, 5. Okay, don't worry. The classical point 0, 1, and -1. Okay, the 0 es obvio que es the universal, que es the point 0,1. Because 1/2 raised to the 0 power is 1. This is the x value and this is the y value and the point, no? Because any number of expression raised to the 0 power, I know that 1. Okay, good. 1, positive 1 is 1/2 raised to the 1 power is obvio que 1/2 because the power 1 is invisible. Entonces 1/2 is here. This point is the point 1, okay, noise, putting off the microphone. And -1 is 1/2 raised to the -1, and you know the interpretation -1 is reciprocal. Entonces just 2 over 1. 2 over 1 is just 2. No? Not necessary to write 2 over 1. It's just 2. And the point -1, 2 is here. This is the point. This is 2. So -1, 2. This point is -1, 2. Entonces we have some idea how it look like. Look like that. No? It decay. Makes sense. It decay. 1 point, 2 point, 3 point. Important, super important thing. Any exponential function contain one horizontal asymptote on the x-axis. Okay, the equation is y equals 0. End the story. That is important. The asymptote is part of the graph. You omit the asymptote, I subtracting 5 points at least. But the asymptote is super important. Okay, let's do one convention. To do this graph elegant, we need the universal point, get this. And 2 points to the right and 2 points to the left. In this case, we have only 1 and 1. No. I have one more. Suppose 2 and -2. Okay. If 1/2 raised to the 7 power, we have +2, and 1/4. 1/4 is a half of the half. This is 1/2. Half of the half is 1/4. The point is this point, que es the point 2,1/4. And -2. -2 is 1/2 raised to the -2. Immediately I see negative reciprocal, flip it. Entonces 2 over 1 squared. And this is 2 squared over 1 squared. 1 squared is 1, it's invisible, and 2 squared is 4. And the point is 4. 4, the graph will look like that. This is 2, continue. This is 3, this is 4. And this is a point here, another point, is the point negative 2, comma 4. Because this exponential continue like that. Okay, decay. Any question? But no. I want to see also in decimal. Well, professor, okay, this is by hand, I don't care. I like decimal, okay, no problem. No problem. You open decimals, okay. Let's switch into decimal. Switching to decimals. To see more elegant. Okay. You see decimals?
Yes.
Okay. Now I have prepared the graphic of the test number 4, the review for test number 4. The question 1. Look at the question 1. Question 1. Look at that. Is this is the equation in red color. Okay, do so much better projector mode. This is the point. Remember 1 point in the middle is the universal, and 2 points to the right and 2 points to the left. And also the asymptote, the vertical asymptote. The vertical, no, sorry, the horizontal asymptote at y equals. Any story? Any question? Any question? Please come on. Question. I need question. Explain everything again, or one specific piece that you don't understand very well. Clear or confusing? Come on, I want to hear opinion. Clear. Okay, N. Clear. Natalie? Clear. Okay, super. We are the best. I told you, we are the best. Okay. Let's go to the whiteboard to solve the question number 2. Question number 2. Whiteboard. Do you see whiteboard? No? Not yet? No, okay, I understand. Now, yes, right? Yes?
Yes.
Let's move on. Okay, yes. Let's move on to the question 2. Question 2. Oh, question 2 is similar. Question 2 is do the graph of another exponential. In this exponential, the base is 4. So the function is graph the function f of x equal 4 to the x power. Doing. And also with this. Okay, remember 0 is the famous universal point gets here, 0,1 and 1 and 2. And -1 and -2. Okay, the exponential is 4 to the x, and when you evaluate 0 es obvio que 1. That is the reason que es 0,1 point, universal point. And 1 is 4, it's just 4. And 1 is 4. Entonces es 1, 2, 3, and 4. Okay, es that point. Is the point 1, 4. Okay, this is x value. This is the y value. And 2 is too much. 16. 16 is, too far. Let's see in this the extra point. This point should be 2,16. And -1. 4 raised to the -1 is 1/4. Reciprocal. Nice. 1/4 look like this is 1, this is half. Half of the half is 1/4. Here. This point is the point. This is the 1,1/4. And 4 to the -2 is 1/4 square. And 4 square, I know the 16 because 1/16 is, that's too small here. Okay, approximate that. Let's see in detail in this one. Is -2,1/16. Now we're connecting the point. We're connecting the point. I know that the curve is asymptotically to the x-axis, approach but never touch, and it's increasing too fast. Remember, the exponential increasing too fast. 1 point, 2 point, 3 point, 4 point, 5. And also we have the famous horizontal axis at y equals 0. This is a good example of the exponential growth because it's increasing too fast. Any question? Now let's explore in this one now to see more clear the last part of the 2,16 that was not clear by hand because it's too large, the graph. Okay, let me try. Switching to decimals. Okay, I suppose you see decimal, right? Yes or no? Okay, this is not question 1, it's a question 2. Move. Question 2, the equation is 4 to the x, the typical point are 0,1, 1,4, 2,16. 2,16, look at that, 2,16. 2,16, negative 1,14, and negative 2,116. And the famous horizontal asymptote, y equals 0. Remember the asymptote always using black color dollar line. Any question? Entonces, in the test que I want to send today, when the class is over, you're waiting for me. You stay here and waiting for me some second. Immediately using another computer, I will send the test number 4. The first question is this. But I don't know if the base is 4, if the base is 5, if the base is 2, if the base is negative. Okay, no, negative. The base is negative, but it's 1/2 or it's 1/3 or it's less than 1. You need to know that when it's less than 1 is decay, decreasing, and when it's greater than 1 is increasing. This is exponential growth. Any question? Any question? We are strong or no? No problema. We practice, I promise, in a few minutes, the logarithmic. So that's the question 5 and 6 in the review package. Okay. Everyone have calculator or no? In this moment, you have with you now the calculator or no? 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 Without calculator, we cannot pass this part. Remember, we need to compute exponential, we need to compute logarithmic. Okay, let's move on to the question 3. Do you see the whiteboard now or no? Yes or no?
Yes.
Yes.
Okay, super. Question 3 is a word problem. The word problem says the growth of the population fits the exponential function p of t is equal to 346. 46. E exponential is the Euler constant 0.05. Okay, this will look like similar to the thing we studied before. Okay, it's the population to population. Okay, let me try to explain this. This is the population where t represent the time or the years since 1979. So let me explain. I don't understand anything. This is the time, no x, because my independent variable now is t. And in the y-axis we have population. At the beginning, is t equals 0. Today no. The beginning of this process, okay, the problem say que es 1978. We have, this is t equals 0, And when you put a 0 here, any number raised to the 0 is 1. So it's 346. I don't know si es bacteria, si es human being, si es rabbit. It's a population of something. Okay? The problem do no specification. Now, and one duration of the time, t equal, I don't know, question mark, que es 2011, the population increasing exponential. Ooh, okay, I need to determine exactly the problem say how many, no? How much, estimate the population, estimate. The population here is this number que I don't know. Es obvio que es exponential growth because the base is E, and E, you know, is approximately 2.718, irrational number. Now this is exponential. Ah, see, we have negative here. Oh, it's decay. But no, we have no negative. We have positive. This is increasing. Is exponential growth. Okay. Entonces, I have two question mark, this question mark, and this question mark. But this question mark is super easy to determine because I subtracting 2011 minus 1978. And subtraction is 33. The duration of this interval is 33 years. Well, the only thing you should do is plug in 33 into the function here. Population at 33 is equal 346 times E to the 0.05 multiplication by 33, que es the time. Time is 33 years. Okay, so everyone working with the calculator. Okay, I want to explain in detail the idea for the calculator. This is the display of our calculator. Entonces you type in 346. Let me do simultaneous with you. Come on, guys. Everyone put in the calculator, put your finger in the calculator. Put it on the calculator, clear the display, new display, nothing in the display. 346. Multiplication time after. You press after. You press time, multiplication. Some calculators don't need to, because default, you suppose que is the operation que connected to things is time. But just in case, I prefer put multiplication. Now, remember the famous key we used in the last class. We have the key LOG. We have the key LM. But above this key, we have the exponential associated with the same base. It's 10 to the x and e to the x. Basically, we are using these. And how you access to this function? Well, in my calculator, I can see that this key have a white color and blue color. Maybe another calculator, yellow color. No, I don't know. So it's you press in order to access to this the function in different color to white. In my calculator is blue. You press second. You press second key. And after you press the corresponding key, que es this key, and you access to this. So in this moment, you see in the display something like that. E power parenthesis. And inside you put 0.05 multiplication 33. And close the parenthesis. Let me try. 0.05 times 33 years, close the parenthesis, and ready to press enter. Okay, let me know what is the answer that you see. As you're doing well or no. Do you follow me? Yes or no? Do you understand the thing I explained now?
Yes, sir.
Okay. When you get the answer, you send the chat to inform me what's the number that you get. I wait for you. Remember, we have time. Excellent. Inaya, excellent. And I say, Professor, the answer is 1801.61502. This is perfect. This is perfect. But we are talking about population. Population is, whole number, not decimal. Suppose que es bacteria or insect or human being. So you round. You round. This is perfect. So you leave it like that, 100 points. However, more elegant is 1802 because that digit is greater than 5. And this is the final answer. Any question? I am sure everyone get this answer in your own calculator or no? Okay, who have problem? Who have problem with the get the answer in the calculator? All right, go ahead. Speak slowly and clear. Come on.
Yeah, when I finished, I put like 346, and after I press Ellen
See,
in my calculator, but it's not working. I don't know.
in your calculator, what kind of calculator you have, Ernie?
Sharp,
What?
sharp.
Chart. Mm. Could you show me your calculator? You activate the camera, and you show me your calculator to see if I can help. No, no.
Yeah, I can show you,
Okay.
but I don't know if it's gonna be okay.
There are several. Show me.
Mm,
A ver. Oh, I don't see anything.
Yeah, that's why I said
It's not clear the image.
no.
Pero okay. Bueno, one possibility is you email me. I try to find in internet the model, at least the picture of this calculator. We communicate again to try, to explain this idea.
No problem, bro. Thank you.
Okay. Email me. I try to find the model in internet. I see the picture. I study in detail the picture. So I indicate you what key you need to press.
All right, thank you.
Okay. The rest of the students are doing well or no? No problema with this word problem. You understand very well the idea, the essential. Similar to this, you can see in the test. No big deal. No big deal. No big deal. No big deal. Everything okay, guys? I can continue or no? Or repetition again the problem. Gary. Okay. Natalie. Hernandez. Everything okay? Alicia. Robert. Come on, answer me, coño. I need to know your okay, clear. Okay, super. Very well. Let's move on to example 4, que it's a little bit more complicated. Typical of this you see in the test form. Okay, remember, I want to send when the class is over. Number 4 talking about, suppose that you have $15,000 in investment. And this is the present value. It's the money I have right now. Okay. Now, I need to make a decision to invest this money in 2 accounts. Well, the time is clear. The time is 10 years. But we have 2 possibilities. Let me split the paper in 2 parts. The possibility A is compounding continuously. At the interest rate 9.5%. Remember, guys, in the formulas, in the final formulas, nobody using plugging in percentage. This is incorrect. You immediately express in decimal. So you divide this number by 100. is 0.095. Divide by 100 is super easy. You only move the decimal point to place. Normally here, 1, 2, to the left. Okay, now it's ready to apply. And the second option is compounding again, pero semi-annually. Compounded semi-annually. Semi-annually. Okay, and interest rate in this case is 9.2. 9.2%. And decimal is 0.09. And to compare these, I need to compute the return, so the future value. One, future value in the first option, future value in the second option. And you compare what is the best return, is it give me more money, no? Okay, entonces continuous and no continuous, que es semi-annually. Okay, what is the difference between this idea? Continuous is when the money increasing continuous, like that. Ooh, like exponential. Similar to the other problem, no? This is the time, this is the money, in this case, money. And the formula that we are using for this part is future value. The formula that we're using is future value future value is equal present value exponential RT. However, in the non-continuous, que es discrete, que maybe is quarterly, annually, daily, weekly, is the money increasing different, increasing like stairs, like that. Boom, 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 boom. And this step of the stair is in the case semi-annually is you have 1 year and divided 6 months, 6 months, semi-annual, so 2 times. So the compounding is 2. And the formula is different. Future value is equal present value 1 plus R over N, raise everything to the NT. 2 different formulas. Okay, let's do it one by one. Future value is equal 15,000. Multiplication, exponential. R is 0.095 multiplication times 10. Everything is the exponent, guys. Okay, let's do it in our calculator. Let me try to explain. This is very, very similar computation. You put like that. This is the display of the hour calculator. 15,000 time 15,000. Let me try my calculator. 15,000. 151230 time exponential. It's the same key. Second LM. I can see in this moment in my calculator now E power parenthesis. Inside you put 0.095 times 10 and close the parenthesis. 0.095 times 10 and close the parenthesis and press enter. Or equal, it's the same. Boom, I have the answer.
You got 30, 78, 5.
Exactly. Typing in your chat.
No, I just want to compare. I don't see my chart. Let me just.
Oh, okay. Don't worry. You say it's 38785 point.
Yeah.
Point what?
Point 64, 48, 9.
64. But the rest, remember, we are working with the money, and the money you round to the near cent. So it's actually is 489, no? So you round to the near cent. Si next digit is less than 5, you remove this. The answer is $38,785.64. This is the return of future value in this account. Very well. Very well. Very well. Let's do it in the second account, and we compare what the best option. Okay, it's 15,000 again. 1 plus R is, in this case, was, I don't remember, 0.092 divided by 2, no? Because it's semi-annually, and the compounding is n equal 2, no? Raised to the multiplication n, que es 2, n is 2, and t is 10. And together is 20, okay? And make it sense it is 20 because actually we have 10 years, 0, 10, 1, 2, 3, 4, 10. But each period you divide it by 2 because it's semi-annual. So the money increasing like that. This is my money. This is my money. It's 1 year. This is 2 years, for example. This is my money. This is my money. So the stairs, of course, the stairs have not the same height because it's exponential, increasing more. Okay. Entonces, make sense to get 20 because 20 is actually is the amount of period that we have in our investment, 10 years, but each year you split in semi-annually. Okay, ready. Entonces, en my calculator, I type in something like that. 15,000 multiplication. I like multiplication always, just in case. 15,000 multiplication, open parenthesis. Inside the parenthesis, I put 1 plus 0.092 division 2, 1 plus 0.092 division 2, okay, close the parenthesis, and power 20, and power 20. Boom, I get the answer. Tell me. I'm waiting. Come on. What's going on? You don't know, you know. Okay. The answer is 36. Okay, I agree. And 40 cents. Yes. The answer is 3687.39.892. And you round to this, and this digit is greater than 5. So you increase in this 39 plus 1 and 40. So say $36,874.40. Okay, and this is the moment to compare this return and this return. What is the best option? What is the best option? Continuous or semi-annually? Huh? Best option. This is the idea in this problem. Any question? Any question? No problema. Clear. I need to hear something. Come on. Clear. Okay, Samantha Cruz. Okay. 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 All good. Natalie Navarro. Okay. Okay. Let's move on now to the graph again. But now graphic logarithmic functions. Question 5, question 6. Question 5 first. Question 5 is do the graph. Wait a second. Do the graph. Graph. This function, que es f of x, equal logarithm base 2 of x. This is non-standard base. Okay. Entonces the graph. Let me see. The graph by hand. Let's do it by hand. And after we are using decimal to see elegant, super elegant. Okay, remember, the universal point in the logarithmic function is here, 1, 0. The universal point in the exponential was 0, 1. But remember the logarithmic is the inverse function of the exponential, and you interchange x and y. Entonces 1,0. Interchange, like that. And the reason is clear. The reason is clear because logarithm base 2 of 1 is 0. This is x value, this is the y value. 1,0. This is always, logarithm 1 is always 0. Now, you can plug in any arbitrary value using the calculator, but no. Much better get nice answer. So I propose you always plugging in inside the argument of the logarithm function number case represent like a base, like a power of 2. 2, 4, 8, 16, or reciprocal, 1/2, 1/4, 1/8, no? Because it's easier. Suppose 2. Well, 2. 2 is easy because when this number inside the argument is exactly the same of the base, the answer is 1, always. 2,1. That point is the point 2,1. Now logarithm base 2 of 4. I don't put 3 because 3 give me a decimal, stupid decimal in the middle. Don't say no. Well, you can, of course you can, but it's no elegant or polite. It's 2, no? It's 2, right? Remember, there are many ways to compute that. One possibility is, for example, you have no idea of this number and you convert to exponential. When you convert to exponential, the base is 2. That this is small 2, I put big 2. The exponent you don't know, and the answer should be 4. And if you have elementary exponential equation, you try to find the common base because 4 is 2 to the second power, therefore the exponent is 2. And the answer is 2. This is one possibility. Another possibility, professor, I never understand this. Okay. You put in the calculator, but in the calculator, remember, in the calculator we have a standard base, and 2 is not standard. So this operation we cannot put in the regular calculator. Maybe in some sophisticated calculator you can, but in the regular calculator, no. Entonces you convert from non-standard base, que es 2, to a standard. Entonces, for example, you put log of 4 divided by log of 2. I am using the change of base formula in this case. And you put in the calculator this and you get 2, for sure. So you have no excuse to don't understand. Professor, I don't know how we compute any logarithm. Using the intuition by hand or using the calculator. Using the chain of base formula. You change non-standard logarithm, que base 2, and the calculator have no base 2, but you convert to a standard. Maybe another student prefer using a natural logarithm like that. If the answer is the same. The answer, of course, is the same. Okay. Okay, entonces 2, a ver, let me see, 4, 3, 4. This is 3. This is 4. 2. This is 2. I have this point, que es 4,2. Entonces, at least we have one portion of the logarithm function. Look like that. One. The logarithm function is, the scale is not good. It's increasing, but the increase is too slow. No es the most slow in the world, but it's super slow. Compare, for example, with the linear function. Linear function is a line like that, increasing faster than this. An exponential, it's crazy, like that. Okay. We finish now. We need to plug in also the number between 0 and 1. Remember, logarithm of 0 do not exist. It's undefined. But we try half logarithm base 2 of 1/2 and -1, no? And -1, right? Then you plot that. -1. Here, -1. Here, 1 point. And logarithm of base 2 of the 1 over 4, 1/4 is negative 2, no? Make sense of this number or it's weird for you? I can explain different way. Okay, so now basically enough. Well, let me plot 1 over 4 que is here and negative 2 que is here. Another point here. Okay, this point was 1/2 comma negative 1. This point was 1 over 4 comma negative 2. Okay, we're connecting this. I can see that the logarithmic function is asymptotically to the y-axis, so approachable, never touch. Therefore, it's important information to do this, the asymptote line. Okay, by the way, it's vertical line, vertical asymptote. Vertical asymptote at x equals 0. Okay, guys, this is horrible. My logarithmic graph, not good. That is the reason I want to repeat again in decimal, no, to see very, very elegant. Any question? Any question? No. Okay, but I'll switch into decimals. Why not? Okay, now this one. This is the question 2. It was exponential. Now question 4 is the logarithmic base 2. Look at that. Wow. Look at that. I plot more point. I plot too much. I plot the famous 1,0, 2,1, 4,2, and 8,3 because logarithm base 2 of 8 is 3, no? 0.5 que es 1/2, negative 1. 0.25 que es 1 over 4 is negative 2. And don't forget the vertical asymptote at x equals 0. End the story. Logarithmic graph. In this case, it's easy because the base is greater than 1. And the test, I don't know, say put 2, 3, 4, 5, 6, 7, I don't know, greater than 1. And the next question, number 6, is when it's less than 1. So you see something different, no? It's decreasing. In this case, the increasing function, but when it's less than 1, it's decreasing function. Okay, let me try next question so you have no doubt. Everything is clear, guy? Let's move on to the question 6. Question 6 is the same. You do the graph of the another function logarithmic, but the only difference is that the base is a fraction. 1/2, no? Yeah, 1/2. Maybe in the test is 1/3 or 1/5. Okay, entonces the graph is similar, no equal. Well, we have the famous point 1,0. It's a universal point in the logarithm because logarithm of 1, I know que es 0, regardless the base. Que 1/2, que 2, que 3, que 1/3. Es okay, classic. But logarithm of 1 is 0. Let me try with the logarithm, for example, 1/2, 1/2, when it's the same. You know the 1, right? So when this number, so this is a property number 2. When you study the property, I study the logarithm any base of 1 is 0. And logarithm of the any number of the same number, so when the argument number is coincident with the base, the answer is 1. So 1/2 is here. And 1, I suppose, is here. This point is the point, 1/2, comma, 1. This is 1/2, guys. Entonces, continue in the same direction. Logarithm of 1/2 of the 1 over 4, I suppose que es 2. Yes or no? Make sense? Or no? Let me try to prove. I am not sure. No, not sure. I put it here. Entonces the base is 1/2. The exponent, I have no idea. I lost. Equal 1/4. Oh, pero 1/4 is 1/2 to the second power, que es 1/2 raised to the second power. The same exponential. The exponent should be the same. Therefore, x is 2. Therefore, x is 2. Super. There's 1/4 here. 1/4, 2. This point is 1/4, 2. Let me try to do at least one piece of the logarithm. Logarithm, remember, vertically to the y-axis, connecting this point, and connecting this point. You see clear que es decreasing, no? It's decreasing. Yes, it's decreasing. Okay, decreasing. Okay, let me try now the number after 1, 2, 3, 4, 5. Of course, no 3. 2 is excellent because it's the base. O sea, logaritmo 1/2 of 2, eso porque es negative 1. Make sense or no? Negative 1. Remember, exponent negative 1 is reciprocal. So when you raise 1/2 to the negative 1, get the exponent. Remember, the answer for the logarithm always. Mister, we can see the whiteboard. Ay, coño, sorry. Sorry, Natalie, and the rest of the students. Okay, I repeat again the idea. Okay, let me switch. Now, okay, I repeat everything at the beginning. Thank you, Natalie. Repetition. Question 6 is do the graph of the function f of x equal logarithm base 1/2 of x. Let's do it. Again. X, Y. Okay. Let me start for the classical point 1,0. I understand very well this point because logarithm 1/2 of 1 is 0. Remember. Logarithm is the property number 1 of the any base of 1 is always 0. So when inside the argument you have a 1, regardless in the base we have the number, I don't care what number it is, the answer is 0. Another property that we study is logarithm 8 of 8. When there are perfect coincidence between the number inside the argument and the base, the answer is 1. So therefore, logarithm base 1/2 of 1/2 is 1. It's logical, right? So 1/2 here, 1/2 is 1. This point is the point 1/2, 1. Likewise, logarithm 1/2 of the 1/4 should be 2, right? Yes or no? Make sense in this or no? Or no clear this? No clear? Confusing? Because what is exponent? Que es necessary to raise 1/2, 1/2. When you square, the exponent is 2. Give me 1/4. It's over, right? This is the idea behind this. So 1/4 is half of the half here. 1/4, 1/4 is 2. Okay. This point is the point 1/4, 2. Let me try to take advantage of this moment that we have 3 points. 1 point, 2 point, 3 point, and connecting. You know que the graph is asymptotically to the y-axis approach, but never touch. Because you know that any logarithmic function have a vertical asymptote here on the y-axis. Okay, so let me try to complete the part to the right of 1. So maybe 2, 3 no, because 3 is no power of 2. You can, of course, put it in the calculator. 4, yes, is good, and so on. For example, logarithm base 1/2 of 2 is negative 1. It's negative 1 because it's the reciprocal, no? The base is 1/2. When you raise to the negative 1, flip it, it's 2. Okay, entonces negative, 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 negative 1, 2. Here. This point is the point, 2 comma negative 1. And one more, and that's it. Logarithm 1/2 of 4 is negative 2. Because actually we are doing two actions. We flip it and square. You flip it, 1/2 is 2, and square is 4. Ah, very good. Negative 2 here, and positive 4. When you're connecting, then this is the point 4 comma negative 2, no? So when you're connecting, this point, and the rest of the point is something like that. And don't forget, please, never the vertical asymptote is always at x equals 0. That's it. This is the picture of the question 6. Any question, guys? You feel good in the logarithm and exponential because the normally. Alicia is a yes. I don't know. This is the terrific part. Terrific, no, horrible part of the. Inaya is a yes. Okay. Okay, let's move on to Desmond to see the elegant graph. Remember, guys, you can. Okay, I do in the whiteboard because I want to explain. But in the real life, you open Desmos, no? Okay, this is question 4, no, 4, no, 5. You open Desmos. You put equation. By the way, in Desmos, don't allow, or at least for me, put 1/2 in fraction. So I need to put 0.5. Do you see Desmos? Do you see Desmos, right? Do you see it right now? Okay, good. I tried to explain when I put 1 division 2, don't allow me. However, I put, okay, let me see where you can find that function. Okay, in the keyboard of Desmos, look, you click here and function, miscellaneous function, and you use exactly this. Because we have LN and LOG. This is standard. Base E, base 10. But arbitrary, no base, no standard base, sorry. It's LOGA, and you need to specification the A value. A value, when I try, I put one division 2 because it's 1/2. No, entonces, no. Desmos don't understand this. However, I need 0.5, it's the same. Okay? It's the same. Now, here, look at that. Wow, amazing. It's decreasing. You see it now, it's decreasing. Decreasing. The famous universal point, 1,0. To the left, 2 point, 0.51 positive, 0.25, 2 positive. To the right is 2 comma negative 1 and 4 comma negative. And also don't forget the vertical asymptote case here at x equals 0. Any question? Wow, easy. No? Okay. Okay. The question 8 is super easy. The question 8 contains ABC question inside this. So question 8 is basically convert to logarithmic form. One exponential statement is given and you convert to logarithmic statement. No? We have A, B, and C. A is 3 to the minus 4 equal 1 over 81. Of course, this is true, super true, but this is exponential statement. Yeah, I want logarithmic statement. I skip 7. Coño, claro. Thank you. Natalie always help me. ¿Es Natalie o Miss Brown? Natalie, ¿no? 7. Sorry, 7. I'm crazy. Well, 7 is the same idea. 7 is the opposite. It's convert from, no, logarithmic. That the final is exponential. Exponential. Entonces, give me A, que es logaritmo base 2 of 1 over 32 equal -5. This is good. This is true, super true. The only is que you should no claim that. The idea is que you transform it to exponential, and that's it. Then it's a logarithm base 3 of 1 over 243 is equal -5 again. It's a coincidence. And C is logarithm base 2 of 1 over 1024 is equal -10. Okay. So my goal is transform it to exponential. So you put an arrow, you put 2 exponential. Remember, there are no formulas, using the common sense. Look, you ask by your focus in the first problem. What is the base? Oh, the base is 2. This is small 2 here. I put the big one because it's the base. What is the exponent you raise to? The answer for the logarithm is -5. The answer for the logarithm is always the exponent. It's equal to the rest, 1 over 32. Okay? Come on. Who help me to try the conversion to exponential in the B and C? Come on, one by one. B first. Come on, help me. You ask by yourself, what is the base? What is the exponent? And what is the result? Base, what's base?
3.
3. The exponent you raise 3 is?
-5.
And the answer is the rest, 1 over 243. Okay. The other is the same, no? I don't want to repeat this idea, no? It's 2, the exponent -10 is equal 1 over 1020. Super easy. Conversion. Do you understand? Do you want to explain like the general formula? I don't like the formula. I like the concept. The thing you retain in your brain is the concept, not the stupid formula. The stupid formula you can find in the book. However, some people, no, I prefer professor the formula. Okay, the formula is, in the exponential world, we have one base. We have one exponent. I suppose that the answer of this I want to call result. I call result, but I call Maria Jose. The name is result. When you change in this direction or in this direction, you put log because of the logarithm statement. And this number, que es the base, you put here small. Open parenthesis. And the answer for the logarithm always is exponent. And the result, you put inside the argument of the logarithm. End the story. This is the formula. Okay? Any question? And number 8 is similar, but in the opposite direction. So I give you the exponential, and you convert to logarithmic. So we have 3 exponential, ABC. The exponential is 3 to the -4 equal 1 over 81. 2 to the minus 5 is equal 1 over 32. And 4 to the minus 3 is equal 1 over 81. No, 64 because of 4. 64. 64. Because it's logical, no? Because this minus indicate reciprocal, no? 1 over, flip it. And 3 to the 4th power is 81. And 4 to the 3rd power, 4 times 4 is 16. 16 times 4 is 64. Okay. But this is not, I don't claim this statement. I suppose it's true. My goal is change to exponent to logarithmic. To logarithmic. To logarithmic. Then you copy the famous word log. L-O-G. So I asked myself, what's the base?
Log
Again,
3.
log 3. Open the parenthesis, equal something. So I remember the base is 3. Nice. The number out, so the answer of the logarithm represents the exponent. And the exponent is negative 4.
Yeah, negative.
And the number inside the argument is 1 over 80.
1 over 80.
End the story. Likewise, here is logarithm of base 2, because the base is 2. Open the parenthesis. The answer I know get the exponent, 1 over 32. Conversion from exponential to logarithm. The base is 4. The answer is negative 3. And the number inside the argument is 1 over 64. End the story. End the story. Okay. So we finished the first page in the review. Okay? But we have time. Any question, guys? How do you feel?
Strong.
Strong. Okay.
This one is easy.
Well, for you, mister. For you. Do you remember when you start with me, intermediate algebra?
Yeah.
Entonces you improve a lot, right?
Yes.
Entonces in few years, you become like a professional, engineer, scientist, I don't know. It's up to you.
The name of Jesus.
Business. Okay.
I'm a nurse. I'm enrolled in nursing.
Okay. Okay, number 9 question is write. You need to write as a single. But basically, we have several logarithmic, single logarithmic, logarithmics, like a name, logarithmics with coefficient 1. Coefficient 1 que es invisible, ¿no? So basically it's condensing. In this case, we have several logarithmic. Okay, for example, A is 7 log of 8 of the one expression, que is C, okay, letter, minus 5, log base A of W, okay, of W, no problem, plus 4 log base A of P. The base must be the same. Si it's different, we cannot condense. Pero si it's the same, you can condense. And so you apply the property. In this case, you apply property 5, property 6, and property 7. Wow. Because when property 5 is when there's addition, is multiplication. And property 6 is when there's subtraction, is division. And property 7 is the factor in the front, you put like a power. So you copy only one log, base A. Now, inside the argument, we have, this is positive. This is also positive. So this is Z in the top. The positive you put in the top. Okay, C to the exponent 7. Okay, you put this 7 here, like exponent. And time, because it's plus, it's time, B to the 4th power. And W no. W is negative, so it's the bottom to the 5th power. End the story. You condense the information in only one log using the property. Okay? Everyone follow me? B. B is 1/2 log base 2 of A minus 1/3 log 2, again, the same base of B plus 1/5 log base 2 of C. I need to condense. Okay, and only one. Logarithm base 2, of course, because it's 2, 2, 2. Okay, so we have positive and positive in the top. This is A exponent 1/2. This is C times C exponent 1/5. And this is negative, so at the bottom is B exponent 1/3. Guys, don't forget parentheses always to enclose everything inside the argument of the logarithm. You can leave it like that. For me, this is super perfect. However, some people prefer using radical notation, no? Because they don't like the fraction exponent, no? This is a square root, A. This is times 5th root of C, and it's a cubic root of B. Either way, guys. Either way. Either way. Any question? C. C is a little bit long. It's logarithm base 5 of x plus logarithm base 5 of y minus logarithm base 5 of c plus logarithm base 5, wow, of a plus logarithm base 5 of b. Too long. Plus logarithm base 5 of c. And they want you condense in only one. Okay, we have 1, 2, 3, 4, 5, 6. Wow, 6. So you condense in only one. Base 5 again, no? But we have a fraction. How do you know that we have fraction? Because we have positive and negative. The positive is this, and this. You put in the top. X times Y times A times C. This time multiplication. The negative guy is this and this. Oh, wait, I make a mistake. Here is minus. In the paper, in the review packet. So it's no C. No C. Let me erase the C. And the negative in the bottom. C times C. And don't forget the parentheses can close the expression inside the logarithm. Any question, guys? Is it super easy or no? You need to be familiar with the property, you know? The property is when this addition is multiplication, when this subtraction is division, when this multiplication is a power. Okay. Let's complicate a little bit more. Suppose number 10 is more interesting. Because
you're
number...
not missing...
Yeah. Did you say something?
Yes, you're not missing B where it says log 5B.
I suppose, yes, of course. I'm missing B. Okay, a ver, X, Y, A, and B. B where? In the bottom, or in the top?
The top.
Exactly. And C, que es negative, and another C, que es negative, is in the bottom. Yeah, thank you.
You're welcome.
Okay, that means you pay attention. Okay, write the logarithm as number 10. Number 10 is super interesting. This is typical. You can see in the test. Why? Because involved, so it's completely opposite idea. No? that you write, I give you one logarithm, boom, and you expand using several. So completely opposite, it's the same property, but in opposite direction, no? So number 10 is write the logarithmic I forgot H always, TH. Right, let me write TH MS logarithmics as a sum, wow, as a sum or difference of logarithm. So for example, A, let me do the first one. A, logarithm of base 2 of inside the argument we have 1 over 16 W6 P3. Wow. Okay. I suppose que the operation que connected here is time, no? And we have exponent 6 and exponent 3. Okay, so we have, look, we have logarithm base 2, we expand of the 1 over 16 plus logarithm base 2 of W6 is plus because of multiplication. But this exponent I put in the front, inside the argument you put just W. Plus, likewise, 3 logarithm base 2 of P. Okay? And we finish, no? No, why no? Because when you have numerical, you see that the first guy is numerical. This no numerical, it's a variable, WP. But we can find that value. No, leave it at that. So you leave it at that, minus 2 points. I need to find logarithm base 2 of 1 over 16. Remember, you can use a calculator or intuition by hand. Okay, help me, guys. What do you think about logarithm base 2 of the 1 over 16? What's the answer of this? So what is the exponent? When you raise the base 2, give me 1 over 16. -4. Very well. The answer is -4. So the final answer that I want is -4, not like that, plus 6 times logarithm base 2 of W plus 3 times logarithm base 2 of P. That is the final answer. Everyone understand very well why logarithm base 2 of the 1 over 16 is equal to -4 or no? Yes or no? Everyone understand this or no? Everyone? Yes. Alicia is a yes. Another opinion, guy. The rest of the student? Let me see. Kyla, are you there? Miriam, Inaya, Victoria, Robert, Alicia. Alicia is yes. Okay, yes, for me. Okay. No, yes, no. Okay. Okay, let's move on to another problem. Both B is similar. But remember, Victoria. Remember, the numerical part you need to compute. Suppose the next example, que es logaritmo base 3 of 81 a squared b6 divided by c4 d5. Okay. Basically, inside the argument we have 1, 2, 3, 4, 5. So we need to expand it using 5 logarithm. We have 5 elements. The first one is logarithm base 3 of 81. Entonces now in the top always is plus 2 times logarithm base 3 of A plus 6 times logarithm base 3 of B minus, because the bottom is minus, 4 times logarithm base 3 of C minus 5 times logarithm base 3 of D. But again, we have numerical. I need to find this, the logarithm base 3 of 81. Remember, think about what is the exponent necessary to raise 3 in order to get 81. What is the exponent necessary to raise positive 4? Very well, positive 4. So say positive 4. The answer is positive 4. And you copy the rest. I don't want to copy again like that. The answer is something like that. Okay? Any question? Do you understand very well why logarithm base 3 of 81 is positive 4? I remember we are doing several times this. Okay, number 6 is logarithm base 5. Entonces we have one expression que es 625. X to the 5th power, y to the 6th power, over c to the 6th w squared. Okay, 1, 2, 3, 4, and 5. Logarithm. Logarithm base 5 of the 625. I need to compute that, but when I finish the span, plus 5 times logarithm base 5 of x plus 6 times logarithm base 5 of y minus logarithm base 5 of z minus logarithm base 5 of w. I forgot 6 here. A ver, 6 here, the coefficients, I forgot, I don't know why, and 2. Okay, these 2 is this 2. 6 is this 6. Okay, now we'll focus and compute the logarithm base 5 of 625. So what is the exponent you need to write? Remember, you mentally, you convert this to exponential. The base is 5, I put the big 5. I like put the big. When I convert from logarithm to exponential, I put the base big. And the exponent, I have no idea. It's equal 625. And 625, I put in my calculator 5 times 5 times 5 times 5 until I discover it's 5 to the 4 power, no? So 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. Therefore, it's obvious that the answer is x equal 4. The answer is positive 4. I replace this by positive 4, and the rest I copy exactly. Question. Okay, guys, so let's do it one more. Today we're doing very well. Because I want to left the super complicated part for the Monday. One more is easy, super easy. It's question 11, and that's it for today. Remember, you stay here with me because in another computer I prepared the email with the test form. So we can start, if you want, doing the test form. Don't worry, don't rush. Remember, this is due December 10th. Remember, you are working now in the homework, free test and test. Number 4, online. Remember, any question that you have about the homework, online, okay, I know it's hard. You email me. Take a picture, but take good picture, no bad picture. One picture I can see the problem, no? I solve for you, I send back. This is the process of learning. Okay? Okay. Let me try 11, and that's it. 11. 11 is easy. 11 is you have evaluate to 4 decimal place. Okay, evaluate to 4 decimal place. Okay, basically the thing it tried to suggest me is can you round to the 4 decimal place. Because we have different non-standard logarithm. Okay, I don't care. I'm using my famous formula that I want to explain now. Is the chain of base formula. I want to copy the formula. I want to explain the formula one more time. And we apply directly in the problem. So we have one fantastic formula que is called chain of base formula que allow us to change from non-standard base to a standard base. And a standard base we can compute it with the calculator. For example, a logarithm of the any base of the one specific number que I call x is equal division to logarithm. Log of x alone. Remember, when the no specification of the base is because we are using a standard base 10. Exactly the logarithm that we have in our calculator, no? Logarithm of a. Or another student prefer using natural, and the answer doesn't change. So immediately I convert this in one expression que contains two logarithms, log of 23.5 divided by logarithm of 12. Boom. I put in my calculator. You try to put in your own calculator. When you put the number, don't forget close the parenthesis. Open the parenthesis, close the parenthesis in the logarithm. When you press the key log, automatically the calculator opens the first parenthesis. But you need to close the parenthesis to indicate the end of the logarithm. Now division log of 12. Press enter, boom, boom. Where's the answer, guy? Where's the answer? I'm waiting for you. I'm waiting for you. I'm waiting for you. You are totally lost? Oh no. 1 point, oh, exactly. Okay, the answer is 1.270. Okay, and I can see in the display of my calculator 470431, something like that. Guys, don't necessarily this is the same in any calculator. Remember, we are working with the irrational number, and the approximation is depending on the electronic part of the calculator, the accuracy. See, it's much better or not. Okay, so you round to decimal 1, 2, 3, 4 decimal place. They want 4 decimal place. And next digit is greater than 5. So you're increasing. This is 1.2705. End the story. Any question? No. Okay. Let's try the other 2 more. You help me. I don't want to participate in this. This is up to you. Is B is logarithm base 5 of the 528. And C is logarithm base 1/2. Ooh, 44. Let me explain something. Let me explain. When the base is a number greater than 1, like a 5, and the argument is greater than 1, the answer we expect is positive. However, when the base is less than 1 and the number inside is greater than 1, the answer we expect is negative. Another case, suppose, another totally hypothetical, D, que es logarithm base 1/3, and we have 1/28. If the number is less than 1 or less than 1, the answer is positive. Since they are contradiction, greater than 1 is positive because we have no flip it. We have no reciprocal. In this case, we have reciprocal. In this case, no reciprocal. When it's both are greater than 1, it's positive. When they both are less than 1, it's positive. When the one is greater than 1 and another is less than 1, it's negative. And makes sense because it's reciprocal. Okay, this is extra que I included in the game. Okay, come on, working. Everyone. 2 point, okay, the first one, no? Inaya, 2.8952. 3, what did you say? Let me try Inaya. Yeah, you are right. A 3 point. Inaya. For B, okay. 3.8952. 52, no? Inaya, it's okay? I did okay? Because the next digit is 0. Okay. Come on. Everyone is agree with Inaya? Let's move on to see. I expect negative value. Yes or no? Okay, es logaritmo of 44 divided by logaritmo of half. You put in fraction, in decimal, either way. Bang. What is the answer in the C? Eso, bueno, negative 5.4594. Yes. 4, 5, 4, 5, 9, 4, no? Is it okay? Or no? It's okay, was okay? Yes. 69, no. What is this? This is the last one. N. 369.06 is what the answer for the C or for the D? N. And the first one?
Yes, sir. In the first one, I got this.
No, in the first one, was 3.8952. Inaya did that.
Yeah, Asima is different. I don't know why.
When you try again, maybe you make a mistake in the number or in the parentheses. Okay, let's do in the last one. The last one is logaritmo 1/28. Close the parentheses, division. Logaritmo of 1/3. I expect positive number. Yes, it's positive. What's the answer? What's the last one? Que es extra. To illustrate that when both numbers are less than 1, the logarithm is positive. Come on, guys, waiting for you. Eso. 3.0331. 3.0331. Super. Perfect. Super. Perfect. We are the best in Miami-Dade College. I have no doubt of this. Okay, guys. So now stay here, please, with me. Okay, because I want to send a test 4, and you can start working with this. Let me know if you receive. If you receive and you have no question, you can leave if you want. We need to wait